Alright, y'all. So number one here, they're giving me two functions. F of x equals 5x minus 1. G of x equals x squared minus 5. They want us to find, F composed G of 1. So they're giving me a number to put in on this one. So y'all, let's go to the pad and work this. Now, since they're giving me a number to put in on this one, we should end up with a single number on this one, okay? So F composed G of 1 is the same thing as F of G of 1. So in this problem, we would work G of 1 first. Once we get the answer for G of 1, we put that into the F function. So y'all, the very first thing, G of 1. Take our G expression and put a 1 in for the X. So that'll give me a 1 squared minus 5. All right, so working that, 1 times 1 is 1. So I get 1 minus 5, which is a -4. So since G of 1 equals -4, we're going to put a -4 into the F function. So we're finding F of -4. So that'll be 5 times -4 minus 1. All right, y'all, so 5 times -4 gives me -20 minus 1, which gives me a -21. Okay, so just look at the order they're giving you. F composed G. If it was G composed F, this would be backwards, okay? All right, y'all, so it looks like we need to put in a -21. All right, y'all, then we hit next. All right, so number 2, F of x is x plus 22. G of x is going to be x minus 22. So on this one, they want us to find F composed G of x, G composed F of x, and the domain of each of these. And it looks like they want my domain in interval notation. All right, so a little more work on this one. So y'all, I'll start out with F composed G of x. So remember, that's like this, F of G of x. Now, since they didn't give me any numbers on this, and what we'll do, since G of x is the innermost function, we'll take this G of x and put it into the x for F. So the whole function, since I can't get it down to a number, this whole function will go into that x. So if I put x minus 22 in for the x, I'll have x minus 22 plus 22. And y'all, if anyone's on there and wants to know, what's this simplified to? All right, good job. That's going to be x because my like terms are going to cancel each other out. So I'm left with a x. So for F composed G, we got an x. So now let's do G compose F of x. So that'll be the same thing, but reverse. So this time, since they didn't give me a number for x, I will put the whole F of x function into G. So F of x is x plus 22. I put that in for the x, and then I still got a minus 22. And it looks like the same thing's happening, right? We got a positive 22, negative 22. Those are going to cancel. So I'm left with x on that one. All right, so let me get my domains. Well, when you work this one, there was no fractions involved in this problem at all. So since I didn't have to worry about a fraction with a denominator that could equal 0, my domain is going to be from negative infinity to a positive infinity. No numbers had to be excluded on that. And then you would do the same thing over here. No fractions, so there's no way to get anything undefined. So there's no numbers I got to kick out. So that domain would be from negative infinity to positive infinity. All right, so the trick is getting all that put into MATLAB. All right, so we say that equaled x. This one equal to x. And then it looks like both my domains were negative infinity, comma, positive infinity. And then the same thing down here, negative infinity, comma, positive infinity. All right, so just make sure you put these domains in interval notation like they want, okay? Now, y'all, number 3 is a little bit trickier for us. Now, y'all, so number 3, it's the same type problem as number 2, but this one, they're definitely giving me fractions. I got 3 over 1 minus 7x, and then g of x is going to equal 1 over x. So we're going to do f compose g of x, g compose f of x, and the domains of both, okay? All right, y'all, so let me bring the camera down a little. So let's start out with f compose g of x. So that's going to be f of g of x. So y'all, what we're going to do is take this g of x and put it into the x on the f of x. So that's going to give me 3 over 1 minus 7 times x, which is 1 over x. So it's going to look like f, except for that 1x is now a 1 over x. Now, when I do my domain, that's the first spot I'm worried about right there. But we'll look at that in a little bit, okay? All right, so the first thing I'm going to do is multiply straight across. So treat the 7 like it's a 7 over 1. So I get 1 minus straight across. 7 times 1 is 7. 1 times x is x. Alrighty, so at this point, remember, we can't have a final answer with a fraction inside a fraction. So on this problem, what we're going to do to get rid of that fraction is we're going to multiply all 3 parts of this problem by x. So you got to do the multiplying to everything on here, okay? So you would have 3 times x on the top, 1 times x minus 7 over x times x. So everybody gets multiplied by x. So y'all, let's see what happens. I get a 3x on top. On bottom, 1 times x is x. Minus, look here, these x's cancel, leaving me with a 7. So the 2 places when I do the domain that I'm going to worry about is right there. This x cannot equal 0, because that would make that undefined. And right here, this x cannot equal a positive 7. Because 7 minus 7 will make that 0. So these two numbers, when I do my domain, I'm going to kick them out of it, okay? But y'all, first, they wanted us to do g of f of x, which is g of f of x. So this time I'll take the f function and put into the x on g of x, okay? So that's going to give me 1 over x, but x is now 3 over 1 minus 7x. So in a second, I'll be worried about this variable right here. So I'll solve that to see what my x cannot equal at that point. So that's one point I'm going to be worried about on the domain. Okay? Now, what I'm going to do to this one, remember this is like a 1 over 3 minus 1, 1 minus 7x. So what I'm going to do is multiply the top and bottom by 1 minus 7x. And then on the bottom, 3 over 1 minus 7x, I'm going to multiply that by 1 minus 7x. So what you do to the top and bottom, remember, got to match. All right, y'all, let's see what happens on top. 1 times anything is anything, so that's going to stay 1 minus 7x. But y'all look here on the bottom, the 1 minus 7x is cancel, leaving me a 3. Alrighty, at that point, I got a fraction. I don't have a fraction inside of a fraction anymore, so I'm good with that. So now let me look at my domains. On my first function here, I said x could not equal 0, x could not equal 7. So my domain will be negative infinity to 0, union 0 to 7, union 7 to positive infinity. Now, the second one, I was only worried about that 1 minus 7x. Remember, 1 minus 7x cannot equal 0. So what you can do is take the 1 minus 7x, set it equal to 0. Once we solve that, we'll have our second number, or our second domain. All right, y'all, here I'm going to subtract 1 both sides to get negative 7x equals negative 1. Divide both sides by negative 7. So that cancels, and I get negative divided by negative, we'll make that a positive 1/7. So on this domain, we're just kicking out the 1/7. So we go from negative infinity to the 1/7, union around 1/7, and then head towards positive infinity. All right, y'all, so my functions were the 3x over x minus 7, 1 minus 7x over 3, and then my domains. All right, y'all, so the first one, let me make that look like a fraction. And I had a 3x on top. And on bottom, x minus 7. On g of x, that's going to look like a fraction. I had a 1 minus 7x on top. And then on bottom of that, we ended up with a 3. So my first domain was negative infinity to 0, and then 7 to positive infinity. So that'd be d. And on my second one, I had negative infinity to 1/7. So that would be d. So usually the domains on that problem are all going to be multiple choice, okay? Hey, y'all, so I'll make this a little bit bigger. Now, on this one, they don't want to know if it's a function. They want to know if it's one to one. If it's one to one, it has to pass the horizontal line test. And remember, the horizontal line test says that if it touches the horizontal line to the graph more than once, it's not one to one. Well, y'all, if you run a horizontal line across that graph, it's going to hit it on the left side and the right side. That means it's not one to one, so you're going to put no on that. Remember, vertical line was for functions, horizontal line for one to one. Okay? All right, also number 5, determine if it's one to one. If it's one to one, find the inverse. They're giving me f of x equals x minus 5. All righty, so y'all, let me just say this. Number 5, it will be one to one. So if you put not one to one, you will miss that one, okay? All of these are one to one on number 5. All right, so since it's one to one, and actually if you was to graph that, you would see that it was a line, okay? Going uphill to the right. All righty, so now, since it's one to one and I'm going to find the inverse, my first step is to change the f of x with the y. So you get y equals x minus 5. Then we had to switch the x and y variables so that you get x equals y minus 5. Now you have to solve for y. So to solve for y, I'm going to add 5 to both sides. So I get x plus 5 equals y. Now, since I've got it solved for y, I'm going to use the f inverse notation. So when you see f with a -1, that means this is the inverse function, and it's x plus 5. You'll notice the inverse function always has sort of like opposite signs than the original function, okay? All right, y'all, so y'all just go throw that in on number 5. Um, Come here and put in a x plus 5. Remember, do not choose B on that question. Going 6 is the same thing. F of x equals a square root x minus 5. So they're giving you 4 answers to choose from on this one, but do not choose not one to one because you will miss that, okay? This one is one to one and it will have an inverse just like the other one, okay? So I'm going to solve it the same way. Make this f of x a y. Switch the x and y, so I get x equals square root y minus 5. Now, you cannot add the 5 to both sides while it's under this little square root. So the first thing you want to do is get rid of the square root by squaring both sides. Because that's going to give you x squared. When you square a radical, that cancels out the radical and you end up with the y minus 5. All right, so now to solve that for y, add 5 to both sides. And y'all get an x squared plus 5 on the left side. That's going to cancel, leaving me a y. So we're now solved for y. So now use our f inverse of x notation. And inverse equals x squared plus 5. So that's the trick on your inverses, okay? replace f of x with a y, switch the x and y around, and then solve for the y, okay? All right, y'all, so we want the one that had x squared plus 5. Now, since this one ended up as a x squared plus 5, they'll have that little domain thing on there. So let me show you. So we had the x squared plus 5. You see that comma with the x greater than 0? That means that we're only considering the right side of that graph, okay? Because if you look at the left side and the right side, it wouldn't be 1 to 1. So they're restricting the domain on that one. So don't worry about the x greater than or equal to 0. You're just looking for your x squared plus 5, okay? So you would definitely use B on that one. Anytime you get an answer that's a parabola, they will restrict the domain to only being to one side, okay? There you go. So that's a trick on that one. So next. All right, so they want us to choose the correct graph. This is an exponential graph. Exponential graphs always have the same look. Okay? Now, all these go from -5 to 5 on the x's and the y. So if you wanted to graph it on your calculator and you want it to look exactly like that, let me put this in. I had y equals 2 exponent x. Now I'm going to go to the window and I'm going to make this go from -5 to 5. I'm going to make this one go from -5 to 5. So as long as you match the window when you hit graph, there you go. Remember, all the exponential graphs sort of go slowly uphill at first, and then they start getting really steep going up, okay? You know, there's only one that looked like that exponential graph, and that would be D. So remember, all our exponential graphs look like that D, okay? Alrighty, y'all. So number 8 is going to be one where we had to sort of move it around a little bit. So they're giving us f of x equals 2 to the x plus 3 minus 5. So we're starting with y equals blank to the x. Our base is a 2, so we would put in a 2. So this is on y'all, though. Shift it blank 3 units. Now that 3 is being added to that x up there as an exponent. So would y'all go up, down, left, or right? All right, so I got y'all on that, right? All right, remember, anytime you attack the x, you're either going left or right. Since they're adding 3, it's actually going to go left. So remember, adding to the x is left, subtracting from the x will be right. All right, y'all, then it says shift it blank 5 units. Well, that 5 is being subtracted at the end. Anytime we subtracted at the end, it went down. So left 3, down 5. Then you got to click to enlarge the graph. Remember, the exponential tool is the second tool on the second row. Click anywhere. Now, the big thing on this, whoops, where'd my box go? Y'all, let me start this over. All right, so exponential graph, click anywhere. Down here on the base, you got to change that base from an E to a 2. You got to change the base on this, okay? All right, then we went left 3, so that'd be a horizontal 3 left. I went down 5, that'd be -5 on vertical. Once I got my 2 moves in there, I'm going to save that and go to next. All right, y'all. So Melissa's sixth birthday. So what am I on, number 9? So sixth birthday. She gets a CD for $2,000, earns 5% interest, compounded semi-annually. Matures on her 15th birthday. They want to know how much money will be available. All right, so this one goes back to the first formula we learned in 9.3. Um, we had A of T, the amount in the account at any time T equaled P times 1 plus R divided by N, all raised to the N times T. Now this one, they want it rounded to the nearest cents, okay? So let's fill in what we got. T was the 2,000 we're starting with. Then we have our parentheses, 1 plus. So R is the interest rate, that's 5%. So remember, move that decimal left twice, and you'll get a 0.05. Over N, which is the number of compounds semi-annually, that's twice a year. So N will be 2. And then that'll be N times T. So what we got to figure out is, what is our T? So she got it on her 6th birthday, matured on her 15th birthday. So that means our T will be 9, which means we're finding the amount at 9 years. Now remember, we're going to round this 2 decimal places. So y'all, I'm going to go to my calculator. We'll quit that screen. All right, so I had 2,000, parentheses, 1 plus 0.05 divided by 2, close parentheses. My exponent was 2 times 9. There y'all, so let's hit enter. We know it's got to be more than 2,000 because that's what she started with. So after 9 years, she had $3,119.30. So that 1 has a 7 after it. So I'm going to round that 1 up into a 2. So we got $3,119.32. All right, so they got the money symbol up here. All we're doing is putting in 3119.32. Okay, do not put the money symbol in. It will mark it wrong since they've already got it there. Oh, y'all, here's something we know how to do. What is the log base 10 of 100? Remember, you're finding the exponent that you got to raise 10 to equal 100. So how many times you going to multiply that 10 times itself to equal that 100? And then y'all remember, you can use the log on front of the calculator even, because anytime there's a log that don't have a base, it's understood to be a 10, right? And that'll be 2, perfect. But y'all remember, you could use the log on front and do log 100 and get an answer. Or you could go to math and down to log base. If you want it to look just like it, go to log base. put in a 10, and then your 100. But either way, you're getting a 2 on that, okay? I took 2 to 2, then next. All right, so number 11, they got a log base 4 of the cube root of a 4. So now the first thing I did on this was convert this radical into a fractional exponent. So I brought down my log base 4. So the number I'm changing is going to be the exponent for the 4 here. Now remember, radicals are written as fractional exponents. Since the 4 didn't have an exponent by it, it would be a 1. So that's going to be the top number. The little index or the number in this notch is the bottom number. So that's a cube root. So that would be a 1/3. So we had a property that said the log base of that base raised to an exponent always equaled the exponent. Um, Now, let me see, go back to Math Lab. And what they want there is 1/3. So convert your radical into a fractional exponent and then use the property we learned, okay? All right, so let me explain this problem. We're going to convert it from exponential to logarithmic, and that's a little g and a little m. So when we convert it, it's got to be the same way, okay? So for number 12, they're giving me g to the m equals 25. All right, so we'll start out by writing log. The base of the log is the same as the base of the exponential, so that'll be g. The result of the exponential is the result of the log. That's going to equal the exponent, which is equal to the exponent of the exponential, which is a little m. So y'all, we're just doing this conversion we learned. Right? So that little conversion is all we're doing on number 12. So we would put that one in. So we got log. So I would write log base g. So come down here and get the little subscript. Put in your little g there. Arrow right. Put in your 25. And then that's going to equal a little m. All right, y'all. So that's in. We would hit next. So 13, using the same conversion, but we're going the other way. 0.001 equals -3. All right, same thing, but we're going the other direction. And they're just being a little bit trickier on this because they didn't give me the base here. But I know that if there's not a base there on a logarithm, that base is automatically a 10. So we know that's really a 10 there, okay? So the base of the log is the same as the base of the exponential. So bring out your 10. The -3 is the exponent of the exponential. So 10 to the -3 is going to equal that result 0.001. Okay, so just use this conversion to put everything over, and then we'll throw that in MathLab. So we had 10. Come down here and get your exponent of -3. Arrow right. That's going to equal 0.001. Okay, y'all, so just convert it, put it in, and then next. Hey, y'all, so this one just wants us to use the calculator to find the common log. That's the log right on front of the calculator. We're going to round it 4 decimal places. So that is a log of 15. So hit the log button, hit 15, hit enter, and that's going to be one of 1.176. All right, the zero's got a 9 after it, so I'm going to round the 0 up to a 1. So 1.1761. Now, y'all, let me show you a trick. If you're rounding 4 decimal places, you can hit mode and come down here where it says float. If you arrow right and put this on 4 and enter, it'll round you off 4 decimal places. So y'all watch what happens. Let me clear that screen and hit enter. And it rounded me off to 1.1761. Now the thing you got to do is watch out, because if you round off on this, usually I put mine back on float to put it back in normal mode, so that when I hit enter, it's back in normal, okay? But the calculator will round off for you. All right, y'all, so we got 1.1761. All right, y'all, so this one, change of base, that's where we go to math and come down and get that log base, okay? So this one has a log base 700 of 11. And once again over here, they want me to round it 4 decimal places, okay? So let's go to our calculator, clear that out. So if you want to, you can set your mode to 4 on this one, or just round it off by head. So here we go, math, go down to log base, enter. Our base was 700, arrow right. That result was 11. So I'm about to find the exponent that'll give me that and hit enter. So it looks like I'm getting a 0.366. So this 0 has a 3 after it. So I'm going to leave that a 0. I'm only going to round up if the number after it is a 5 or greater, okay? So that would be a 0.3660. All right, y'all, moving on. Oh, y'all, express as a product. That's that was the power rule of logarithms. And all we did to express it as a product, we pulled that exponent down to the front and rewrote that as a product. So bringing that exponent down, you would get a 20 times log. Now that's a log base 10. You can put the 10 there, but you don't have to. But I'll do it. I'll do the subscript, put my 10 there, arrow right, and then put my y. So all you're doing is bringing that 20 down to the front and rewriting it, okay? So it looks like we're starting to get into our um, properties here. All right, y'all, so let's, this one wants me to rewrite as sums or differences. I got a log base b of x to the fifth, y to the eighth, and a z. All right, so we just had these. Since these are both being multiplied, you would rewrite them as sums. If they were being divided, then you would have some differences in there, okay? So I got three factors, so I'm going to distribute the log base b to all three factors and write them as a sum. But there's one more thing we had to do to this. To be fully simplified, we got to invoke the power rule on these exponents and bring our exponents down to the front. So here I would get 5 log b of x, plus here I would get 8 log b of y. And then that only had a 1 there, so that's not changing anything. So that'll come down as a log b of z. All right, so it's rewritten as sums. So we would go put that in the math lab. All right, so I have 5 log, and then I got to do my base down here. Subscript b, arrow right, and put in an x. Plus 8 log, go my subscript b again. Arrow right, put in my y, and then it was plus log. See, every time you write log, it highlights it. And then that was a base b, and then arrow right, and put in your z. All right, y'all, so 5 log b of x plus 8 log b of y plus a log b of z. Once you get that in, hit next. All right, so this one's being subtracted. A log of 10,000 minus a log of 100. So y'all be careful on this one. I'll show you what you got to do. So first of all, since they're being subtracted, I'll write it as a single log. If they're being subtracted, we write it as a quotient. Now, they want us to simplify 10,000 divided by 100. So that equals what, 100? So that's the first answer they wanted. So you would go in and put in the log of 100. Since they got log there, they want you to put this in first. And then this thing simplified even further. So we know what the log of 100 is. Y'all did that while ago. And the log of 100 equaled what? What you got, Olivia? 2. There you go. That'd be a 2. Okay. All righty, y'all. So simplifying, that's where we had write this as 1. So we had a ln x squared plus 6x plus 8 minus ln x plus 4. So this one we had to write as a single log and then get it simplified. So remember, since they're being subtracted, we would write it as a quotient, x squared plus 6x plus 8 over the x plus 4. Remember, the factors being subtracted always went to the bottom, and the ones that were positive went to the top. But y'all, to simplify this, we're going to have to factor the top. Nothing we can do to the bottom at the moment because that's just one x. The top had an x squared. So that'll be an x and an x. That last number is positive. Since the last number is positive, both of these factors will be the same sign as the middle. So these are both going to be positive. So what you want are factors of 8 that'll add to get a 6. So you would break down 8. How do you get that? A 1 and an 8 and a 2 and a 4. That's the only way to get an 8. And the ones that add to get 6 are going to be 2 and 4. So put in your 2 and your 4. You now notice that the x plus 4s will cancel. So your final answer will be an ln of x plus 2. And you have to keep the parentheses on this one, okay? Gotta keep the parentheses. So we would go put that in. Oh, they got all the answers here, I guess. So A had it written right, but it wasn't simplified. C, I don't know what they did. B, I don't know what they did, but there at D is our ln of x plus 2. All right, y'all, so and let's go to Math Lab and see what's next. Only on this one, they want us to solve. I got 2 to the 9x minus 1 equals 4. So y'all, what I'm going to do on this one, this is an exponential equation. So my first step would try to rewrite each side using the same base, which I can do on this one, because I can rewrite 4 as 2 squared, okay? So you want to rewrite each side using the same base. Now, since my bases match, that means the exponents have to be equal. So 9x minus 1 has to equal 2. And then at this point, we're just going to solve for x. So let me add 1 to both sides. That's going to give me my 9x. That cancels. 2 plus 1 gives me 3. And in my last step, divide both sides by 9. So that gives me a 1x. So I can't divide 3 by 9, but I can reduce this fraction. Since the top and bottom both divide by 3, I'm going to divide the 3's out. So 3 divided by 3 gives me a 1. 9 divided by 3 gives me a 3. So I end up with x equals 1/3. So y'all, I would go put that in. Now they've already got the x equals, so all I need to do is 1 divided by 3 and be done. All right, so I think another one. So 21 e to the negative 0.57 t equals 0.99. All right, y'all, so let me show you what I do on this one. Since this is a base e, I'm not going to try to rewrite 0.99 using a base e. That's pretty much impossible. So what I'm going to do, since that's a base e, I'm going to take the ln of each side. So that's going to equal the ln of 0.99. Now, we got to do the property. Remember, this ln is really a log base e. So I got log base e of e to this exponent. Remember, anytime the base of the log matches the base raised to an exponent, this whole side equals the exponent, which is negative 0.57t. That's going to equal the ln of 0.99. So to get this t by itself, I'm going to divide both sides by the negative 0.57. So that's going to equal my ln of 0.99 divided by negative 0.57. Now remember, when you punch this in your calculator, make sure you close those parentheses on that ln, okay? So that I get t. Now they want me to round it 4 decimal places anytime you do ln's or logs, 4 decimal places, okay? So let's go to our calculator, clear everything off. So alpha y equals enter to get my fraction. I had an ln of 0.99. Close those parentheses. And then I'm dividing by negative 0.57. All right, y'all, hit enter, round it 4 decimal places. So that's going to be a 0.017. So the 6 has a 3 after it, so I'll leave that a 6. So 0.0176. So that's what we're going to throw into MathLab. And see, they're saying round it 4 decimal places as needed. So 0.0176. All right, y'all, at that point, hit next. All right, so what's this? 22. Solve for x. I got log x equals negative 6. So on this one, when you got a log equal a number, we wanted to rewrite it as exponential. So there's not a base here, remember, that means the base is a 10. So I got 10. Exponent to be the negative 6. That's going to equal x. All right, so on this one, they want you to write it as a decimal. So let me see if the calculator will do that on that one. So I got 10 exponent negative 6, enter. So it's doing it as scientific notation. I figured it would be on that one. But y'all, the trick on that, let me show you. What you would do on this one, since that's a negative 6, you would write a 1 and then move this left 6 times and put your decimal. So you would go 1, 2, 3, 4, 5, 6. So you got a 0, 0, 0, 0, 0. So that would equal a 0.0000001. Okay, you always put a 1, and since it's negative, move left 6. Okay, if that's a 5, I'd move left 5, and so on. That's going to equal my x. So you gotta, I think on that, you gotta convert it into that decimal form, okay? All right, so 0.0000001. All right, so if it's a 6, I need 5 zeros. If you had a 7, you would have 6 zeros, and so on, okay? All right, y'all, so this one, log base 7 of x equals 1 minus log base 7 x minus 6. So y'all on this one, since you got a logarithm, a number, and a logarithm, you want all the logarithms on one side. So I need to move this log 7 x minus 6 to the other side. So since it's being subtracted, I'm going to add log 7 x minus 6 to both sides. So over here, I get a log 7 of x plus a log 7 x minus 6. Over here, um, those cancel, and all that's left is the 1. So on this one, first thing, move that to the other side by adding. Now, I got two logarithms equal to a number, so I'm going to write this as a single log. Since they're being added, it'll be rewritten as a product. So log base 7 x times x minus 6 equals 1. Now, I usually go on and multiply this out real quick. So I got a log 7. X times x is x squared. X times negative 6 is a negative 6x. All this equal to 1. So at this point, you got a log equal to a number. We're going to rewrite it as exponential like we did here. So I got a base of 7, exponent of 1. That's going to equal the result of an x squared minus 6x. So since we got an x squared here, we need everything on one side equal to 0. So 7 to the first is basically 7. So I'm going to subtract that 7 from each side. So that gives me 0 equals x squared minus 6x minus 7. So at this point, we got a factor. X squared is an x and an x. Last number is negative, so we got unlike signs. One will be positive, one will be negative. I need factors of 7. That'll subtract and give me 6. The larger number will be negative. And y'all, there's only one set of factors for a 7. And that's going to be 7 times 1. So 7 minus 1 gives me 6 like I needed. So the larger number 7 is negative like the middle. And then the smaller number will be positive. All right, so you got it factored. Now set each factor equal to 0. So y'all, the first one, we would subtract 1. X is a negative 1. Second one, I would add 7 and get x equals 7. So y'all, the question of the day, you got to remember, we cannot take both of these answers, because if you put a negative 1 in for that log, you'd get an error. So you got to throw away that negative answer and only keep the positive 7s. So remember, on log equations, you cannot keep these negative answers if they make you have a log of a negative number. So y'all, I would just put in a solution is 7 and be done with that, okay? All right, so this one's sort of like one we did in class yesterday. So in 2012, population of the city was 5.59 million. Exponential growth rate was 3.23% per year. So A, they want the exponential growth function. B, so let me write this down. Exponential growth function. B, population in 2018. C, when will the population be 8 million? And then D, find the doubling time. Alrighty, so let's go play with this one. So this one I'm using the formula P of T equaled P initial times E to the KT. Okay, so that's what they want for A, the formula we're going to use. So they're going to put the P of T there. We just got to fill in everything else. So the initial population was 5.59 times E. K is my interest rate or my growth rate. But y'all, that's 3.23%. Remember, we got to convert out a percent to decimal by moving this left twice. So that means I'm going to have a 0.0323. So if you move twice, you got to add a zero on this one, okay? So that'll be 0.0323 times T. So now if I know how many years passed, I can figure out the new population. So B was the population in 2018. So we got to figure out how many years passed from 2012 to 2018, and that would be 6 years. So we're finding P of 6. That'll be 5.59 times E to the 0.0323 times 6. All right, y'all, let me check on MathLab and see how they want to write this answer. So for V, so it looks like everything here is rounded one decimal place, okay? So let's go to the calculator and round this thing one decimal place. So I got 5.59. Then I want to hit second ln to get E. And then that was 0.0323 times 6 years. So y'all just hit enter. We're rounding one decimal place. So that's going to be 6.7, but the 7 has an 8 after it. So I'm going to round that 7 up to 8. So that I get 6.8 on that one. So then it says, when will the population be 8 million? So this is the one where I'm looking for my T on this one. And y'all remember on this one, I said to find T, T would equal to ln of your PT over your P initial, all divided by your K. All right, so that's going to be the ln. Well, the ending amount they said was 8 million. So you're going to have your 8. The P initial was the 5.59. And we'll divide that by K, which was 0.0323. All right, y'all, so we would punch that into our calculator. We're rounding it one decimal place. So I'm going to make that look like a fraction. Alpha y equals enter. I'm going to do the ln, and then I'm going to make that look like a fraction inside of it. 8 on top. 5.59 on the bottom. Whoops. Arrow out, then close it. Then come down to the bottom and put in a 0.0323. All right, y'all, when I hit enter, I'm going to round it one decimal place. So I get 11.0, but the 0 has a 9 after it, so I'm going to make that 11.1. All right, then doubling time. Well, that was the capital T equaled ln of 2 divided by our k. So that's going to be ln of 2 divided by 0.0323. Now I know this, it took 11.1 years to get to 8 million. So that's not quite half. I mean, double. Double would be like 10 or 11 million or so. So it's got to be more than 11.1 years. Okay. So let us punch that in and see what it gets. So I'm going to do the, and if you want it to look like a fraction, alpha y equals enter ln of 2, close parentheses, and on the bottom, 0.0323. So hit enter, round it at one decimal place. So definitely more than 11 like we thought. So that'd be 21 point. All right, the 4 has a 5 after it, so I'm going to round the 4 up to a 5 and get 21.5. All right, so now I'll go put all that in. So for A, we had 5.59. E, and then exponent 0.0323 times T. All right. In 2018, we said the population would be 6.8. See, they've already got the million. We said it would be 8 million in 11.1 years after 2018. And then the doubling time we said was 21.5. All right, so y'all, you put all that in. Next. All right, so this one, we're investing 18,587. Interest rate 6.4%. Compounded continuously. So they want the exponential function. B balance after t equals 1, 2, 5, and 10. And then C, the doubling time. All right, so this is like one we did yesterday also. So first I want the formula for A. So it's going to be P of T equals, my initial amount was 18,587. Then I got E to the KT. K is 6.4%. Remember, we're going to move the decimal left twice. So that's going to give me a 0.064. So that'll be 0.064 times T. So now if I know how many years passed, I can find out the amount of money in the account if I started with 18,587. So y'all, that's what they wanted for A. B, they wanted to know the amount after T equals 1 year, T equals 2 years, T equals 5 years, and T equals 10 years. So one way you can do it is put a 1 in for T, see what you get. Put a 2 in for T, see what you get, and so on. So y'all, let me go and look and see how MathLab's wanting these answers. So it looks like they want me to round those answers 2 decimal places. Now, I'm going to use my calculator, but I'm not going to do it individually one by one. I'm going to go to y equals and put in that function of 18587. Second ln to get my e, and then that's a 0.064. Now remember, if you use the graphing calculator, you got to use x's for the variable. Although it's a t, you got to use an x in here, okay? Now I'm going to hit second graph to go to the table. And y'all let me go up to, what was my first one? 1 year. Now remember, if you look at the y right here, it's not rounded off 2 decimal places. You got to highlight the 19815, and then down here in the bar, it's giving you the decimal. So for 1 year, it's 19815 point. Let's see, that's a 45. But y'all, the 5 has a 9 after it. So that's going to be a 46. Okay. Now at 2 years, I'm going to go down. That one was 21,125.11. So the second one has a 0 after it, so I'll leave that a 1 and make that 11. Then I had to go down to 5 years. That's going to be 25,596.6. Let's see, the 7 has a 3, so I'll leave that a 0.67. And then we had to go to 10 years. So at 10 years, I'm at $35,249. So I got an 8. The 9 is in the second spot. It's got a 0 after it, so I'll leave that 0.89. So I would go to Math Lab and punch all them amounts in. Whoops, I got to do my doubling time real quick. So my doubling time was capital T equaled ln of 2 over k. So that's going to be the ln of 2 divided by my k, which was 0.064. All right, y'all, let's go punch that in and see what we get. So get off my graphing. So alpha y equals enter. On top, I had an ln of 2. On bottom, 0.064. And enter. So 1 decimal place, that looks like 10.8. I'm going to leave that at 8 since it had a 3 after it. Alrighty, y'all, so let's go to Math Lab and put that in. So my formula was 18587 E, and then let me get to my exponent here. Exponent 0.064 T. All right, then the balance after 1 year, 19815.46. After 2 years, 21,125.11. After 5 years, 25,596.67. After 10 years, 35,249.89. And then we said the doubling time was 10.8. All right, put all that in. Oh, y'all, this was 25, right? So this is it. So then you would submit it. And be done with it. Hey, y'all, what questions y'all got, or do y'all have questions over that? Hey, y'all, so write this down. Test 4 bonus. I'll send this out later, but my test 4 bonus, I wanted y'all to answer two questions. One of them, what is the log of 1? And the second one, what is the log of 10? So I'll send them out in my uh, notes today, but here's the two bonus questions for test 4, okay?